Helen. Today we're going to use the sine rule to calculate two possible values of an angle within a triangle. Let's have a look at the question that we're going to do today. We have got triangle ABC in our question. Side AB is 5 centimetres, side AC is 4 centimetres, and angle ABC is 40 degrees. And we need to calculate two possible values of angle ACB. Okay, so let's have a look at what this looks like. So, quick sketch. Side AB is 5 centimetres. We'll come to side AC in a minute. Angle ABC is 40 degrees. Let's say it's roughly that. 40 degrees. And side AC is 4 centimetres. So the aim of the problem is to calculate two possible values of angle ACB. So how could that happen? Let's focus on side AC. So our side AC is 4 centimetres. So C is around about here. AC is down here. So let's put that on there roughly. AC just there. But AC could also be like this, and that also be 4 centimetres as well. So AC could be like that, AC could be like that. So we can see that we have two possible values of ACB. ACB could be that acute angle just there, or ACB could be that obtuse angle just there. And they are the two values that we need to calculate. So let's put AC, 4 centimetres just there, and focus on calculating that C. Let's call the other C star. They're obviously different. Okay, so let's have a look at what we've got. We've got a side that we know within this big triangle, and we've got the side opposite the angle that we also know. We've got this side that we know, and we want to know the angle opposite. So as that's the information we know, this screams the sine rule as a handy formula to work this out. And here's a quick reminder of what the sine rule is. The top version, that tends to be used when we are working out a side, and this version when we are working out an angle. So we'll concentrate on the bottom version to calculate our unknown angle. Sine C, which is the angle, opposite 5, equals sine of 40 opposite that side. So if we rearrange that, we get that sine C equals 0.84 to 3 significant figures. Okay, so there, using your calculator again, C therefore comes out at 53.5 degrees, also to 3 significant figures. And there we have that angle C. So how do we extend that to the other angle? Let's consider the sine graph. So do quick axes just here. Y, X. Let's label it. Y equals sine X. Okay, so let's get our bearings with this. Sine C is 0.804. That's roughly around there if you consider the fact that the maximum value of the sine graph is 1. So let's trace that across so that we can see possible values for the angle that corresponds to it. We've calculated 53.5 already. And let's map out other points on this graph. This is 90 degrees. This is 180 degrees. So to calculate the other angle that also leads to a value of 0.804, we have to do 180 minus 53.5. So C star, that obtuse angle just there, is 127 degrees to 3 significant figures. I'll write that there as well. A bit crowded on that diagram. So the answer to this question is that C, the acute angle, is 53.5, and C star, the obtuse angle, is 127 degrees, both of 3 significant figures. So here's a question for you to have a go at. Feel free to pause the video and work it out, and then when you turn it back on again, I'll put the answer there for you. And here's the answer. I hope you found this useful, and good luck with your maths.